Okay. This briefer version of the preceding, and I didn't get that in the better camera. Memory card was full, accident of my own, my fault. Okay. Now, a power function, this standard definition for power functions, y equals f of x equals x to the p, where p is some constant number other than 0. Okay. That's the standard definition. We're not using that definition. We'll come around to this definition. We'll see the equivalence between this and the definition that we use, but that is the standard definition. The definition we're going to use is a power function is a function that's represented by a graph that has a specific property. Property being that the y value changes by some y factor whenever x doubles. And we construct graphs for y factor 3 halves and y factor 5 halves. Okay, so to start, we took the, we marked a point right here on the x-axis, just to the right of the origin, small distance. We set the compass to this distance, and then we used the compass to mark a point, an equal distance from that point. So now we have a point that's twice as far from the x-axis, because of course our definition involves what happens to y when x doubles. It's going to really be helpful to us if we have a series of doubling x values, which we do have here, at least as best I could construct it. Now, we take this distance and we add it to that point and we get this point. Then we take this distance and we add it and we get this point here that's a little bit smudged out. I'm not sure how that happened. Sure I did it, but I don't know how. Okay. Now the compass won't open that far, so I'll use my fingers for a compass. We take that distance and add it, we get this distance. And then we stretch out the fingers a little bit, we take this distance and add it, we get this point. So now we have a series of x values, each of which doubles the preceding. Alternatively, we could have constructed the same points by starting out here. Okay, we arbitrarily mark where this point is, we can arbitrarily mark where this point is, and quite often we'll do that. We'll figure out how far we want our graph to go, and we'll mark a point there, and then we'll cut that in half by bisecting this segment to get this point, and then we bisect this segment, we get this midpoint. We bisect this segment, we get this midpoint, and so forth. So either way, we have a series of x values that doubles as we go from left to right. Now we construct the graph for y factor 3 halves. We arbitrarily chose a point right here, okay? And we marked that point in green chalk. And let me mark that point again. Okay, it's right about here. And it corresponds, of course, to this x value. That is, it's right above this point here. That's the first x value that we marked. Okay, and then we project over here, and we have our y value. Then, using compass and straight edge ideally, we would construct a point that's, well, first we would bisect that little line segment between the origin and this y value. We bisect that and add it, and we get another point on the graph. Now we have a new y value. Well, we bisect that and add it to the original, and we get our next y value, and we continue doing that, and we get a graph that looks like this. Now okay, well, then we constructed a graph for y factor 5 halves. And we started, you see this faint orange line here, we started by starting with the same point that we used for y factor 3 halves. Now there's no reason we had to start with that point, but and we've essentially then declared that the two graphs intersect at this point. They could intersect at some other point. We don't have a scale on this axis. We don't have a scale on this axis. We don't have a numerical scale. We have a bunch of doubling x values, but there is no scale here. Okay, well, in doing that, I had to use factor 5 halves, meaning, okay, I double this y value, then add half of that y value, gave me a point above this second x value that I think is here. Then I double that and add half, and that's a point above this x value, and so forth. That gave us a pretty narrow graph. We can't even really see how that graph curves. Does it curve upward? Does it curve downward? Is it a straight line? The points are aligned in a region of the graph that's just too narrow to distinguish. So we chose a point here. Sorry, I was looking at the time on this thing, and the time wasn't over there because I'm not using that camera. I'm using this one. Okay. So I chose a y value out here. And then I tried to construct the graph based on this y value. Now the problem is, to get, if this is the point I'm starting with, then how do I locate this point? Well, this point is supposed to be 5/2 as far from the x-axis as this point, which means that this point should be 2/5 as far as this point. Well, I can construct 5/2 with compass and straight edge. I can't construct 2/5 with compass and straight edge. The denominator is 5, and that means I'd have to divide this line into 5 equal parts using compass and straight edge. It can't be done any more than trisecting a line can be done. So there's no way for me to construct this. So I had to just kind of eyeball it. Okay, you know, I eyeballed where half ought to be, and then I went a little lower than that to get 2/5. 2/5 being a little less than a half, and I got a point here. Then I went half of that and a little lower and used that for the y value above this point. And then I went a little less than half of that and used that for the y value of this point, and I didn't attempt to construct it any further. I then moved from this point to the right and actually constructed. So this lighter orange line segment here, or curve, this lighter curve, represents something that ought to be pretty close to a factor 5/2 graph. But now I'm going to actually start with this point here and construct it. Now I didn't actually do that on the board, but what would typically happen is you would either end up, depending on how you estimated 2/5 of the various distances, with a curve that either goes above this one or below this one. If you use consistent estimates, it shouldn't go through it at more than one point, but that's also entirely possible depending on how well you estimate it. In any case, if I construct from here and I get this point and then this point and then this point, then I can connect that with a curve, and now I have a constructed curve for y factor 5/2.